There we go. I'm going to share my screen as well. Okay. So sorry, I'm sitting in Germany, so I will turn off my night mode, and now it's day again. Where did Peter left you? Peter left you in the desktop client of Scale Model. So you see behind my desktop client is the web client. Just to show you the difference regarding Scale Result of the desktop client to the web client. Within the desktop client, you have the ability to open here another tab. Open Scale Result for or the result module, for example, and then you are directly in result. Yeah, if you run a simulation, for example, you can directly jump in here as well and say, okay, open. Okay, I have a German client. This means open run results, and then you end up here. Desktop client and web client look exactly the same. So this is basically here the desktop client. This is a web browser and works in every common web browser. So Firefox, Chrome, or Edge, which is now basically Chrome, are supported. And the only difference is that within here, the desktop client, you are directly able to open attachments with your local applications. So just imagine here you want to open this image, you can directly select open, and here my image view, my local image view opens. And this means if you're looking for D3 plot files, for example, you could open them with your post processor, or if you have an Excel file or CSV file, you will directly open it with Excel, or in my case, LibreOffice. Yeah, that's the only difference in the application. Otherwise, they are basically feature complete. So this means in the case of the web client, if you would like to open something for default media types like images, we have inbuilt viewers in the browser. Otherwise, you are able to download them and then, depending on your setup, directly open them with your application. So this is the only detour you have to make when you use the web client. Otherwise, they are completely the same. And here we are. So Scale Result. Marco mentioned in the introduction, it is a cloud native application. So I'm currently running our demo, and at the end we will show a slide where there are contact information. So in order to have access and basically repeat what I've shown you, we will provide you credentials, and then you can access our demo application as well. So our demo application is hosted on AWS, but at other customers we host it on Azure as well, or as Marco was mentioning, on-prem. How does the application look like? On the right, we have the main grid, and each line is equal to a test or simulation. On the left, we have the structure of our test and simulation. So we have projects and collections. Projects in the sense of Scale Model are a little bit the same as the main pool version. So Peter was working in the pool Jahres. So let me open basically the project Jahres here as well. And then we see all the data which is related to Jahres. On the other hand, we have collections. And collections, they work a little bit as a folder. So we will have a webinar, and I prepared something here. So you can structure your data additionally in collections. Each simulation or test needs to be assigned to a project, but each test or simulation can be additionally assigned to a collection. So if you have certain tests or simulations coming from different projects and you want to work on them, compare them, or in the sense of virtual testing, you have projects related to your physical experiments and the same project related to your numerical simulation. You just put them into a collection. And the good thing with the collections is you can keep them private, set read-only or writable, and share them with your colleagues, which are assigned to your discipline, for example, or to your working group. So that's basically about the simulation and test structuring within projects and collections. Here in the main grid, we make this a little bit more tighter. So each line is equal to a test and simulation, and the layout of the grid. So it's an engineering application, and some of the engineers, they are very used to Excel, so it's a little bit Excel-like. You have different column, and each column is representing an attribute of the test. Yeah? Attribute can be a numerical value, string value, or whatnot. And this definition here of the layout is totally specific to the customer and is customizable by you via here the front end. We call this configuration script preset. And as you can see here on top, we have for multiple disciplines or for multiple projects, multiple preset. So I'm currently working here on Yaris. So I select the Yaris demo preset. The next thing I would do is that I select the project. And then within the preset, I have the opportunity to define different tables or views of the tables. This is coming from Excel, the same as having different spreadsheets in one preset, and they are selectable on top here. So if you say, okay, this is now Yaris demo, or this would be your NVH preset, for example, then you can define within this preset here different main views which you would like to have in order to see your data. Additionally, this view or this grid is structurable interactively. So if you decide that you would like to group your data by directive, for example, and then you would say, okay, I need to look for, what do we have here? Maybe I choose a discipline, and I would like to check, okay, only US NCAP, and then I would like to see, do I have front impact or maybe side impact? I think at the Euro NCAP we have both. No, only front. Sorry. Yeah, only side impact. Then you just simply drag and drop the column or the attribute you would like to group by and align them up here. You can change them, and then the order of grouping changes as well. So by this, and here with the right menu, you can further structure and define your data representation in this grid-like structure. And then additionally to the preset, you are able to define this view here and say, okay, this is the view I would like to work in, and just name it my default view. Of course, I did it once. I rename it default view 2. And then at the end, you can just simply select your view, and then you have immediately your view, which you have here. The views are stored to your personal login, but additionally to this, you have the opportunities, if you're an admin, for example, and I'm an admin, to define this as the global default view assigned to your preset. So if you're basically head of the NVH department somewhere, you set up the application, you set up the views, and then you define it as global for the preset. So if your colleagues log in and they choose the NVH preset, then they immediately see the view you've prepared for them. Exactly. Additionally, on top of each column, there are basic filter and search functions depending on the data type. You have here a group selection or a category selection, or normal operations equal, greater than, less than in case of numerical values, for example. So here you can choose this and say, okay, I would like to see everything greater than 56 kph. Sorry, this shouldn't happen. Then in this case, you get an error, but usually it's supposed to work. Okay, so this is basic. These are basic features. If you apply filters or sorting, so you can sort here as well by simply click on them and store them in the views. Filters and sorting rules are stored in the views as well. On the left side, if you remember in Scale Model, you had the run configurations in a tree-like structure. Something similar exists here in Scale Result. We call them scenarios, and scenarios are stored in a preset, so in the configuration file too. Scenarios are nothing else than attribute type filters. So you define in the preset this tree, and for each tree node, you define a certain condition. So if I deselect everything, if I select the first node, then the condition is formulated that each type of test needs to be a front type of test. And if I deselect the others here and maybe I choose North America, then basically the market needs to be North America. And if you then further expand this and choose this node, then each of the tests need to have the attribute directive should be US NCAP. And by this, you filter down the entirety of your simulations. Those filter options, those are the filter options you have. Currently here in the grid, you see 625 simulations. I think Marco or Akbar was mentioning in the beginning at customers which use the application productive. This is a 6-digit number. And by this, the application is still performant and you can scroll through millions of simulations and search and filter them down to a selection you would like to have in order to evaluate or create reports. Okay, let me change to a collection. So it does have 61 entities and maybe we continue here. The bottom part is the part where you see, so within the post-processing, or maybe I go one step back, where's the data coming from? Peter was showing you the use case where you set up in Scale model your simulation, send it to the HPC, post-processing is executed, and afterwards the post-process data, so attributes, photos, videos, some sort or all sort of post data gets uploaded to Scale result. It's not mandatory to live in the entire SCALE.sdm universe. We do have customers which run testing facilities, for example, and for them we offer add-ons where we fetch the data from third-party systems, could be databases, could be file systems. Some customers want to have a manual upload. So basically, if you have a zip file with a certain structure of your facility, then we create or write a custom add-on, and then you are able by simply right-click at your test, basically here via the context menu, and drag and drop the file or the archive from your file system into the application. Additionally to that, the server itself has an open API, so you are able to, you can directly access the API. The API has an authorization layer. So basically, if your user is authorized to access the API or to write data, you can simply write the data directly through the API. So if you have somewhere a third-party system which would like to push the data to Scale result, this is possible too. And additionally to this, we offer a command line interface. So basically on a Windows or Unix shell, you are able to upload data via command line arguments or commands. And you can download the data there as well. So basically we try to keep this application as much as integratable into your existing process chain as possible. So, but in our case, data has been, or simulation has been set up with model and executed on the HPC, and the HPC directly pushes the data here to the application. So what we see down here are all the, let's say, main components of simulations. So we have attributes, which are basically key values. We have photos, videos, documents of any sort. So this could be PDFs or some 3D viewer files or the D3 plot I was showing in the beginning. We have one-dimensional time series, which we simply call channels, measured data, events. Events are a special thing. I might talk about it at the end, and reports. So for all the elements, we have inbuilt viewers. For attributes, it's quite easy. It's just a flat list. But if you are looking for a certain value, and now here we have 811 attributes, you can filter this down. And if you say, okay, I can't remember the speed, whatnot, then you simply filter down the list and see, okay, this was a 56 kph, and this is here meter per second. Same with photos. We have, as I showed, inbuilt photo viewer. So if within your post-processing extraction of post data like images is defined, then they end up here at photos. Same applies for videos. So yeah, you have a possibility to see an animated photo as well. And at documents, we have multiple types of inbuilt viewers. For sure, we have a PDF viewer. So if you have any report or coming from a testing facility, you have a report of your physical test or whatnot, then you can directly open it here in the application. For some applications or some data types, we have inbuilt viewers or particular inbuilt viewers, like for CSV files, we have a tabular data viewer. And again, this is a little bit a substitute for Excel. So searching, filtering, regrouping, everything is possible here as well. So if you would like to group here your CSV file by the element type, you can do this here in this viewer. And this is coming, I guess, from a Dyna simulation where we created the CSV with the check HSP function. In our process here for the demo, within the post-processing, we define model extraction. So we have A and Z files, and they are 3D files. So if you do not want to use your animator or your post-processor to have a look at a certain part of your simulation, which you usually would like to investigate after you run the simulation, then you can extract this part and have a look via our inbuilt viewer, which is the 3D viewer. So takes a second to load, especially if you run with Zoom. So this is basically our inbuilt 3D viewer, and in the post-processing that we defined that we extract the left rail, the right rail, and here the firewall. And I think in the left rail and the right rail, we do have 2 layers exactly. So we integrated some basic tools like selection, deselection. You can fringe mechanical properties like stresses, strains, or plastic strains onto the parts as well. Here's just the color of the part ID. And then, of course, you can investigate how it's going to deform over the progress of your simulation. Yeah, so in order, if you want to make a screenshot, for example, or if you quickly want just to investigate how's the rail behaving, then you can use the inbuilt viewer, make a screenshot. You can basically reduce the view to the part you are interested in, change display, opacity and whatnot, or change here the styling to mesh only. It's a quick way to access or basically get a visual impression and a 3D impression of your simulation, post-simulation data. And channels as well. So in the post-processing, you define the channels you would like to extract, which you might need to determine your performance criteria, which you need to compare in the sense of virtual testing. So at EuroVTC, there's a lengthy list of channels you need to extract, which need to be defined in the ISO MME standard. And those channels you can access down here. For channels, we have an inbuilt plotting tool, which is now available in the latest version and which is still in progress to be further developed. So let me see. So maybe we choose those channels. So here with the inbuilt plotting tool, you can basically create your own plots. You can realign the plots. You can create a new plot. If you say, okay, I want a new axis and I want to have this on another axis, then you simply do this. You can change the entire layout. If you want to see them like this, you can change the units of the axis, you can change the title, and at the end you make a screenshot and include it in your report. Currently we're working on operations. So you have here the calculate option. Simply select one or many channels. And if you say, okay, I forgot to apply a filter, then you choose the filter option, for example, and run the filter afterwards. In this version here in our demo, there's just this short list. We extended now the extreme value identification. You can integrate in the current version, you can differentiate as well. And in the next version, you will be able to store this sequence of operations as a template. And then you just open the template or select the test, open the template, and you get directly to this view. Nevertheless, this is basically here the current state, but this is under continuous improvement with every release. Those basic data like channels, videos, in documents, the table, and here the ANZ files, which are the 3D viewer files and the attributes, you can define in a web report. And I think we were talking to this about this later. A report is nothing else than you start with a blank canvas and you just arrange basically the data you would see in a standardized manner. So if you decide, okay, on top I want a overview table, let's say, with certain attributes. I want an additional table where I want to see my performance criteria or my injury values. I want to see a certain set of channels, and I want to see a certain set of images or photos. Then you simply define this in a web report. The web report is something we call an add-on, and I think Marco was mentioning this. This is basically an HTML. It's written in HTML and in HTML, and therefore it's customizable by you. So simply you can download an add-on, change an add-on, customize this, and upload it to the application, and then the updated version is available. So how does it look like? By the way you align the windows and here these different sections, they are stored in the workspace, which is user-defined. So if you close the application, open the application and log in, it looks exactly the way you left it. And this is the charm of the web browser. If you log in on computer A and log out in computer A, re-log in computer C, the layout is still the same. So here we created a report for the crash discipline. Again, if you have multiple disciplines or multiple purposes where you need a report, you just create multiple reports, upload them to the application, and then you can assign each report to a certain preset in order to make a preset or discipline specific and directly select them down here. And in our case, yeah, we put them all the reports to one discipline, so it doesn't matter. Additionally, here you get an overview, let's say a table of contents of the report. And if you say, okay, I want to go to the images, okay, if you need to expand it, I want to go to the images, then you simply click here and you end up at the images. So let's start at the top. Yeah, as I mentioned, overview table of key values. You can include the diagrams, and here the same plotting component is included. So if you say, I want to run some operations on this, simply select the curve, select the operation, and off you go. Yeah, okay, this is again just channels. You can include tabular data viewer. You can include the preview for the animations. You can for sure include the preview for the images. And on the very bottom, you can include the 3D viewer as well. So a web report is nothing else than a condensed overview or access for a standardized visualization of your simulation or test data. So this means if you select a different test, the report builds up automatically with your new test data. And now, if you select one test or two tests, the rep report gets filled automatically as well, and you get the opportunity to compare the tests. So I think this is a little bit useless here, but let me have a quick look. Maybe it's not useless. Maybe take this one. Sorry. And let me filter them by name. So exactly. So if you have multiple simulations or different simulations and you want to compare them, then okay, maybe both tests do not have the same data. Wait a second. We select a test. Test should have the same data in the simulation. Exactly. So the same, which I didn't mention. Since we treat test and simulation exactly the same, this web report applies to a physical test in the same way as it applies to a numerical simulation. So if you have test and simulation, you can directly select your test and your set of simulations and get a direct overview or comparison and see how good is based on the data, you choose to compare how good is my simulation fitting to my physical experiment or the other way around. So yeah, exactly. As you can see, the web report builds up automatically. The same applies then here for sure not for the tabular data, but for the animations, for example. If I expand this, we see this side by side. Okay, someone falsely named here this view. It's the wrong view, but nevertheless, the principle is exactly the same. So then here you can synchronously compare your simulations with your physical tests. And if you go to images, for example, it becomes more apparent. Okay, that's the web report. The web report is basically the dynamic and interactive report. And I think there was a question how dynamic or how many layers can we include here in this report. So this is basically plain HTML, and you can develop this web report if you want to do it on your own with every front-end development language. So this is basically up to you. You can include HTML drop-down buttons, different modals, and then the complexity is really there are no limits, and it depends on how complex you would like to have your web report. But usually having something which is structured is at least the way usually the customer go for in order to get a step-by-step overview of the data and be able to compare it. By the way, this comparison by selection doesn't only work here for the web report. It works here for those attributes and images as well. So if we close here the web report, if you want to compare your images here, test with basically any simulation, then you just simply select a test in simulation. If you say, okay, I'm looking for a side view, then you get here the two simulations and you one test side by side, and same applies here for for everything down here. Okay, maybe it's not named side. Right. So yeah, and then you can access them here. Exactly. Coming to the reports, so we have an interactive report and we have, let's say, a more static report. For the latter one, I'd like to introduce the concept of add-ons. You can customize and extend this application in the front end as well as in the back end. And this you do with something we call an add-on. An add-on is nothing else than basically a front-end application part and a back-end application part. And by applying or by basically creating an add-on, you have the opportunity to run something on our server in the backend, which runs in an independent container or in an independent container. And by this, you could include any 30 third-part applications. And for the report, I'm going to show you how we did it to include Animato GNS, a post-processing tool to create static reports. So our application, or basically this web report, is to certain points limited. And if you want to have more comprehensive reports, which are very specific to your company or your discipline, then you would like to maybe introduce other applications you need. And this you can easily integrate with, let's say, a static report or an add-on based report. So how does it work with the add-ons? You get here an overview. We do have quite a lot. And we have something which is called Yaris Animator report. So Yaris is the model and Animator is the application we use to create the report. And you simply select your add-on. And here you see the front end of the add-on. And this as well is totally specific to the customer. There are multiple options. We hand out basically templates for add-ons to the customers if they decide they want to program them on their own. Or if they say, okay, we do not have the capacity or the knowledge, then we can do this for sure as well. So, but usually the add-on is the way to extend our application. So by selecting the tests and opening the add-on, you are basically now in the add-on application, which the customer can create on its own. And here we decided to just prepare a nice overview. Okay, we want to create reports for the selected simulation and the selected tests. And if I hit next, okay, we can choose the output format, and then I create create report. What now happens is the backend gets activated, and the backend has a fixed API we provide. So in the backend, we fetch the data now. We do not download the data, but we access the data since it's running in one system. Now Animator GNS gets opened, it processes the data, creates the report, and pushes the final report back to the user, where the user can download the archive, or if you run multiple output files, you get a file list, and okay, now it's just one. Doesn't really matter. Exactly, and based on this procedure, you can include all your applications you need in order to create a report or in order to just include your application. So it can be a computation as well. It can be a machine learning script. Yeah. So if you have a Python script, the in-house developed Python script, which computes something, determines some values or attribute values, creates channels, images, or whatnot, then you can include this via an add-on and directly store the results to the test you've just selected at the beginning. Coming back to the add-ons, you basically see now here, yeah, that's a template, but as you can see, this is equal to our selection. And then we create here a more comprehensive report. Good thing is this is standardized. So if you download it, all the reports will look exactly the same. Yeah. Okay. Let me have a look at the time. Maybe in the concept of add-ons, since there was the question with the VTC, so basically in the virtual testing, at least in the Euro NCAP virtual testing, you have to evaluate some quality criteria, for example, which is a correlation measure for time series, and how we would imagine how such a process could work on that we include. And in Euro NCAP VTC, for example, the Python script or evaluation script has been made public. So we would include such an evaluation script directly in an add-on, select the test and the test and the set of simulations, start the add-on, and then we get a direct overview of the quality criteria, whether it's greater than 0.5 or not. Coming to add-ons, we do have an add-on, or we have a different add-on type, which could be accessed based on the selection in the grid, and this is our data analysis add-on. And for the data analysis, I created a view which is called data analysis, and here we just see the columns of the results. So if you would like to create a data analysis or machine add-on on your own, and you would like, or you need to access basically just the attributes you selected here in the grid, you can do this as well. Yeah, so basically we now select here this range of numerical values and start our data analysis add-on. This add-on, for example, doesn't have a backend part. All the computation takes part in the front-end part. And here we integrated a machine learning library, TensorFlow, and a plotting library for all the data exploration tools. So in the sense of the data analysis, the first thing you can do here is basically define your input variables. What did we do? We changed the barrier offset and we slightly changed the vehicle speed, define them as input, define your outputs, and then you can basically, you're good to go and can go through here the add-on. So what we've included are some basic data exploration tools, scatter plots. Here in the scatter plot view, we integrated, or you are able to determine outliers. And we have three methods. Yes, one is not distance based, so let's go for this. And as you can see, so we detected, this is some arbitrary, not arbitrary, but this is test data. So maybe in the real world data, this would be an outlier as well. But nevertheless, you can basically detect your outliers. You can deactivate the outliers. You get an impression which test has been an outlier. And if you apply a label, for example, then you can say, okay, this simulation has been an outlier and this test has been an outlier. You can determine the correlations. You can filter down the correlations if you look for the most positive, or vice versa for the most negative correlation. This is here a linear correlation. You can run basic trend, linear trend, input versus output. And based on your surrogate model you defined, you can see basically a 2D representation or a 3D representation of your surrogate model with respect to your defined input and output. So let us just change to OLC. Okay, this is how my surrogate model is performing now. Per default, there is just a linear regression, but we will change this soon. Based on the surrogates, you are able to run your sensitivity analysis. So this is based on the surrogate model, first order Sobol sensitivities. And down here, you are able to, first of all, train your meta model and evaluate the goodness of fit of your meta model. So linear regression might be not the one to go for. So TensorFlow, and maybe we add here some epochs. Okay, we just selected 64 data points, so this is not really representative, but for the sake of the demo, you hit compute, and now the TensorFlow model gets created, it gets trained. What you can do with the models, you see here on top, you can download them. And this is actually quite handy because in the case of the TensorFlow model, you can integrate it maybe in an optimization environment. So basically, you have all the nodal values, you have all the weights, and therefore you can evaluate the TensorFlow model in an external application in your process chain. So yeah, as I mentioned, we included some, this is not very well trained here, we included some visualizations. You can check input versus output, and then most likely you just want to see the validation data and have a look how well is it performing. Actually, not so really well, but it's not so off too. But based on this, then you can run basically your sensitivity analysis. So this is now here executed on the meta model number 2, which is the neural network. And the same applies here for the plots. So here you get a representation and forward be able to directly read the data of your meta model. Maybe change here exactly. So, and then you can see, okay, how well is it performing? Exactly. In the case, okay, this might be a trivial because we only have 2 input values, but as soon as you have more input values, you can change here the value of all the input values which are not shown in the grid, which is now makes no sense. But yeah, if you have 3 input variables, for example, you can change the third one to a certain design variable where you think, okay, here my output shall perform well. Then you just adjust basically your design variables here. And then you could make a slight prediction of your output based on this training. Now, the good thing is this is all integrated in the application. And as I was showing, based on this add-on concept, you could integrate your in-house solution if you have some in-house solutions, or you can integrate solutions from other applications. Okay, since we might run out of time, I will say brief words about Scale project. So Scale Result is all about evaluating the results, running standardized reports, running standardized evaluations, and apply your own code based on templates, based on add-ons. And there's another part which Marco was presenting at the beginning, which is somehow the bracket of SCALE.sdm. This is Scale project. So in Scale project, you define your project goals, then you run your simulations, you evaluate your simulations, and then you would like to report your simulation to Scale project in order to get an assessment of your simulation and get a idea of the maturity level of your project. How does it look like? You go to project, select your project Yaris, and here we have a few possibilities regarding project management. You can define milestones. It's not just a visual representation. Based on the milestones, you can scroll through the time. So if you have a change of requirements, I will show you later, you can say, okay, I want to assess my project with respect to this milestone. And or in later process, you can basically scroll through the time and get the time-dependent assessment of your requirements. And therefore, it's quite handy to define milestones. Yeah, documents that's all trivial. The most important part is here requirements. So a requirement is nothing else than, let's say, a way to run a certain assessment of a numerical or of a binary value. So each requirement has a certain name and has certain threshold values which are user specific. So in Crash, customer customer ratings, they usually look like this. So for any injury value, define some threshold ranks and which you need to fulfill. So in the best case, everything is green, and then you want to see an aggregated report. So basically here for, where are we? 56 kph frontal. You see, okay, my status is red. And you can have a look here and say, okay, I have this 4 requirements. One of them is red. Therefore, the aggregated status is red. This is basically the view for the project manager to see, okay, what's the current status, who did what and when. So for each requirement, you get a detailed view and you can say, okay, that's me. He reported today that that the femur force compression is minus 8.1 kilonewtons, and this apparently is not sufficient. Currently, our project status would be red due to this. How does it work here now? On the other hand, there is the engineer who runs the simulations. So how does he work? Let me just reset the view. Sorry. So the engineer runs the simulations, he runs the report, and he thinks, okay, my simulation should be sufficient, so I would like to report the simulations. And maybe he's not quite sure whether 1 or 2 simulations perform better than the other, and he has the opportunity, to directly set the project status. So based on the attributes of the test and the attributes of the requirement, a matching is taking place. So here we see all the load cases of the project which we need to fulfill. Some of them are not matching. So just the first one is matching, because this is not matching, I think, due to the dummy type. And here we see our 2 selected tests, and we see here the quality of the assessment. And then we have the opportunity to go in the details view and see, okay, 1 is green, sorry, 1 is yellow, 3 are green. This looks good to me. You can simply compare this then with the other tests, say, okay, that's apparently not so good. And then select the test. And if you think, okay, this, here I did something wrong, this is the wrong value, this is actually, in the case of a physical measurement, for example, this should be green and this should be assessed green as well. Then you just simply leave a comment. And since you're not quite sure whether this was really a mistake or not, you are able to either directly report this publicly, or if you're not sure, report this just privately. And now there's an error. Yeah, I changed this as well. Sorry. It's mandatory. If you manually change something, it's mandatory to comment it. Therefore, there was an error. Now there's still an error. Sorry, I hit tab all the time. Okay. So now you are able to report it, but just privately. So the public status for the project manager does not get overwritten. You hit save. And if you want to track your own project level, then you could go back here to the view, go to your test case, and see, okay, now everything is green, status looks good, and then you can double check, okay, whether this manual reporting was valid or not. And in the best case, just publish this publicly, basically. Then you can do this here as well and say, okay, save public, and then get stored to public.